So you know how to add and subtract complex numbers. Now we need to look at how do you multiply complex numbers. It's really not that bad. Think of I as being x. And if you can do it that way, you should be able to do this. There's just one little twist at the very end of each problem, but if you think of I as being an x, it'll work out just the same. So if we look at this first problem, I'm going to take 5i times negative 2, and we get negative 10i. And then 5i times I, we get plus 5i squared. So here's the twist. I squared can be simplified, right? Because our definition that we talked about is that I squared equals negative 1. So now I need to replace that with negative 1. Okay, now that was 5 times I squared, and so now it's going to be 5 times negative 1. So we still have negative 10i, and then 5 times negative 1 is minus 5. And so this would be our answer. However, I'm going to ask that you write it this way. You want your real part first, so I want to put negative 5 first and then minus 10i. And so that is going to be your answer for this. Alright, so big twist. I squared is negative 1, so you have to replace it with negative 1 and simplify. Now, you are going to have times where you have a complex times a complex like this. And so in order to do this, we're going to use the box to help us multiply. Alright, so we set up the box. Remember, these go on the outside because our answers would on the inside. So we have 7 minus 4i, and then we have negative 1 plus 2i. And we go through working out the box just like you normally would. So you get negative 7, and then over here we get 4i, 14i, and then we get negative 8i squared. And you'll notice I'm writing it down in the bottom corner because this is going to simplify. This is my box that's going to have that I squared. Remember, I squared is negative 1. So we have negative 8 times negative 1. That gives me a positive 8. So then my answer here, the real part, is negative 7 plus 8 is 1. And the imaginary part is 14i plus 4i gives me 18i. And so there's my answer. All right. Now we'll just keep on doing some examples here. Now we have 6 plus 3i and 6 minus 3i. All right, let's see here. Make a box. Notice that these are actually the same, almost identical bubbles, except for the first one has a plus and the second one has a minus. And I'll tell you right now that something special is going to happen here as we multiply these. So as I work this out, we get 36, 18i. In the bottom left, we get minus 18i. In the bottom right, we get negative 9i squared. But I squared is negative 1. Negative 9 times negative 1 is a positive 9. So my answer is, if I take the real parts and add those together, I get 36 plus 9 gives me 45. And if I look at my imaginary parts, I got negative 18i plus 18i. Those actually cancel out. So I don't have any imaginary parts, so my answer is just 45. All right, my next example. I'm going to take that negative I times 3. I don't need a box here because it's just the I times the bubble. So I get minus 3i. And then negative I times positive I would be minus I squared. But remember, I squared is negative 1. So we get negative 3i. And then we have two negatives, gives me a plus 1. And I'll just rewrite it so it's in standard form, which is the real part and then the imaginary part. All right, a couple more examples. Almost done here on this slide. So here I have 2 plus 3i, and then negative 6 minus 2i. Multiply those, so we get negative 12 minus 18i minus 4i, and then I have minus 6i squared. I squared is negative 1. Negative 6 times negative 1 is a positive 6. So again, I'll look at my real parts and add those together. I get negative 12 plus 6 is negative 6. And then we have negative 4i minus 18i would be negative 22i. And that would be my answer. All right, this last problem. Remember what happened last time? Last time I had this where I had one that was a plus and one was a minus. Let's look up here. Last time I did that, I got 45. So let's see what happens with this one and see if we get the same thing or something similar. So again, I set up the box. I get 1 plus 2i and 1 minus 2i. So in the top left we get 1, on the top right we get 2i, the bottom left we'll get negative 2i, and then in the bottom right we get negative 4i squared, and I squared is negative 1, so we have negative 4 times negative 1 is a positive 4. So then to figure out our answer, we add the real parts, and we get 1 plus 4 is 5. And then when we look at our imaginary parts, we get 2i and negative 2i. Those cancel out once again, and so my only answer is 5. And so you'll notice last time we got 45, and this time we get 5. So if you remember earlier when we were multiplying those two bubbles where they were exactly the same except one was a plus and one was a minus, those are called complex conjugates. So the idea is it's exactly the same. It's A and BI, it's A and BI, one's a plus and one's a minus. And so what's really cool about that is that they, when you multiply them, the i's disappear. It's really kind of a neat thing. So if we're looking at these and I'm trying to figure out the complex conjugate of them, basically what I'm focusing on is that in front of the imaginary, see the real one, A and A, they're still the same. It's the imaginary that changes sign. So here it was a positive BI, here it'll be a negative BI. So as I'm trying to figure out the complex conjugate of 3 plus 7i would be 3 minus 7i. The complex conjugate of 5 minus 3i would be 5 plus 3i. The complex conjugate of 2i would be negative 2i. The complex conjugate of negative 5i would be a positive 5i. Now this one's tricky. The complex conjugate of 6 is 6. And here's why. This 6 is really 6 plus 0i. And so the conjugate would be 6 minus 0i. And technically the 0i's are nothing, so it'd just be 6 and 6. Remember, we're just changing what's in front of I. And so then the other tricky one would be this one. 3i plus 4, the complex conjugate would be negative 3i plus 4. We're not changing the sign of the second thing, we're changing the sign in front of I.